welcome to the last lesson for Unit 8, Astronomy. Today we're focusing in on eclipses, both lunar and solar eclipses, which is what you see right here. We've got a wonderful shot showing a solar eclipse on the left and a lunar eclipse on the right. All right, let's first start out with the lunar eclipses. Now, lunar eclipses just simply mean eclipse of the moon. Lunar is moon, eclipse, it's disappearing behind the shadow. So this is shadows, unlike the phases. And lunar eclipses are when the Earth's shadow falls upon the moon. These are somewhat rare. Now this sketch here that I made up, it's obviously just a sketch, and it's not to scale at all. But it does show the sun shining on the Earth, and the moon has moved behind the Earth's shadow. There's two Earth shadows here. There's a penumbra, which is a partial shadow, which is kind of a play of the angles of the sun hitting the Earth at both sides of the Earth. And then there's the really dark shadow, a complete shadow, and that's called the umbra. Now, a little bonus here. What phase must the moon always be in before a lunar eclipse can occur? And to have a really good lunar eclipse, a total lunar eclipse, the moon has to be on opposite sides of the Earth and the sun. And you know that that is during full moon phase. So we always see these really nice lunar eclipses during full moons, the nights of full moons. Here's a shot showing that. We got the sun shining on the Earth, and you can see how the moon is orbiting around the Earth and moving into the shadow. And there's different types of lunar eclipses. We have penumbral eclipses, which is right here. We have total eclipses when it moves straight through here, and partial eclipses where the moon gets kind of cut off. And let's take a look here at a total lunar eclipse. There's the shadow. The moon kind of turns red a little bit during a lunar eclipse, and that's because the only light from the sun getting around towards the moon is actually refracted by the Earth's atmosphere, and that red-colored light tends to make it around. It refracts, whereas the opposite ends of the color spectrum, the blue, doesn't. So play that one more time for you. There's your total lunar eclipse. And you can actually see the curve of the Earth during that eclipse. More evidence the Earth is round. Remember back to the old Eratosthenes argument we had there. So why are they somewhat rare? Well, you got to remember that the moon doesn't always orbit the Earth the same way. It's actually at a tilt, and the plane of that tilt is about 5 degrees, 5.2 or so degrees from the Earth's orbit around the sun. So in plain English, this is the plane of the Earth's orbit around the sun, and the moon's orbit around the Earth is tilted 5.2 degrees, and that's just enough to make the lunar eclipses not happen every month. And here you can see that there's actually unfavorable times of the year for lunar eclipses, and there's favorable times of the year. And it all has to do with the alignment. So here, unfavorable because the light of the sun is going to go right underneath the moon at that picture and over it there. Same things here. But favorable because here, the way the moon's orbit, the plane of the orbit's tilted, it's not going to make the moon above or below the Earth, and so it's going to get in the way here and cause a potential eclipse, which is another kind of eclipse we're going to get to. And here, get the lunar eclipse. So, this is the whole thing about eclipse seasons, when the times of the year is just right for eclipses to occur. And here you see a lunar eclipse. And this chart from, I believe, NASA shows various lunar eclipses. And you can see that they happen often. They're not really common, but they do happen often. But you just have to be in certain parts of the world to see them. And most of the totals are usually an hour, a little bit less than an hour long. So they don't last that long. You really got to, get lucky and have a nice clear sky the night they occur. But they are somewhat common. And this just shows stitched together photos of lunar eclipse. You can see the light of the moon coming across at a diagonal there. And when the Earth's shadow is covering the moon, you can see it disappears in this area. So that's when the total lunar eclipse occurs right there. It's a pretty cool shot. Now the other kind of eclipse is the solar eclipse. So in this case, instead of the moon being eclipsed, the sun is being eclipsed by the moon. Now the moon's shadow falling on the Earth, it's very rare because the moon is a lot smaller. And you can see in my sketch here, obviously not drawn to scale again, there's a penumbra, which is the partial shadow, and that's played off by the angles of the sun hitting the Earth at different extremes. And then there's the full shadow, which is the umbra, and that's the part that's making a total solar eclipse. It's a real tiny line on the Earth where this occurs. And this is a beautiful stitched together shot showing the sun and the moon slowly moving, and as the Earth rotates, the sun moving too, appearing to move, over the sun's disk. And this is the part in totality right here. And there you can see the corona of the sun. Dangerous to look at. You have to use a special filter to look at that, or else you could go blind. And then it moves back off over on this side. Pretty cool. I've only seen one of these in my lifetime, total solar eclipse, 1994. And why are they so rare? The answer, very, very straightforward. The moon's shadow is much, much smaller than the Earth's shadow. And so you only get these like tiny areas right here where you actually see the eclipse. And you can see it here. Tiny shadow versus a larger shadow. And this is the solar eclipse, and this is the lunar eclipse. So definitely it's a common sense thing. I mean, the Earth's a lot bigger than the moon. And this shot here is nice. It shows total solar eclipse, 2009, July 22nd, and how small of a path or a place on Earth you'd have to be to actually see this total solar eclipse. Only from, maybe over here in India out into the Pacific Ocean. Just that little swath of land is the only place where you're going to see a totality, the sun completely disappear. Everywhere else you're going to see partial in this range. Partial solar eclipse. And if you're anywhere else on the Earth, you don't see it at all. You're out of luck. And then if you're at one of these locations, it has to be clear. Of course, if it's cloudy, forget it. All right, let's take a look at this. So we can see a total solar eclipse on the left, and I'll see if I can pause it right at the moment of totality. No, I can't get it. Let's move it back. Right there, and you can see the corona of the sun. And in the middle shot, you can see a partial eclipse because the moon's orbit's not quite at the right angle. It's just covering up part of the sun. And then the right-hand side shows an annular eclipse, which this is really neat because the moon, remember, it's in an elliptical orbit, and it can get a little closer and a little farther away depending on different factors in its orbit. And so in this case, it's a little bit farther away, and so it's not completely covering up the entire sun. If it were closer to the Earth, it would appear bigger and create a total eclipse, but in this case, an annular eclipse. So it's pretty cool to watch. In all three cases, you should be using eye protection to watch. And here's a chart showing some solar eclipses. They are more rare. And the one thing I want you to pay attention to is during a solar eclipse, you're not going to see it for that long. The actual duration is much shorter, like here, 1 minute and 40 seconds, 2 minutes, 47 seconds. They don't last that long, 4 minutes, compared to the moon, which was like an hour or so. And that's once again because of the small shadow of the moon on the Earth. And this applet's kind of nice. It shows how you can play around with some factors here. Here we got a partial, or if I change the angle, I can make it a total. So it all depends on the moon's angle, the plane of its orbit's angle, as it moves around the Earth. And I love this applet because you can change all that. Now you can also go on to the other side, and you can make a lunar eclipse. And once again, you can play around with the angles. So as the moon moves into the Earth's shadow, you know, if it's right over the middle, it's going to be a total lunar eclipse. But if it's up a little bit or down a little bit, it's going to be a partial. Now the distance we can also change. And if we bring it back over to a solar, that really comes into play here. So if we set it up so that it's lined right up, so we get a total, but we make the moon a little bit farther away, you can see how it's going to be an annular eclipse. Not completely cover up the sun. But if I make it so the moon's a little bit closer, it completely covers the sun. So all these factors play into you know, determining what kind of eclipse we're going to get. And all these things are very cyclic, so you can actually determine them way ahead of time. It's pretty cool stuff. And I figure we'll end the unit with this shot here showing a total solar eclipse. In fact, they call this the diamond ring. You can see right as the moon is kind of pulling away, just for that instant, this picture was snapped, this photograph was snapped, and you can see some solar prominences over here. So cool. And you can see the diamond ring right there. And doesn't it look like a diamond ring? All right, guys. I enjoyed teaching you this unit. And now it's time for Regents Review.